Algebra 1 students, in this video today we're going to be learning how to solve and simplify square roots. Now actually, we're going to do a little more than that. We're going to get into some fractions with square roots, but the overall basic idea of what we're going to do today is we're going to learn how to solve and simplify square roots. So please copy this heading down in your notes. Be sure and include today's date, and like always, if I go too fast, all that you have to do is pause the video and get caught up, okay? So your heading today is solving and simplifying square roots. The lesson number is 9.2, and be sure to include today's date. Now, today's video will be a little different than the usual types of videos that I do, okay? Usually I have stuff all typed up ahead of time like I'm doing right now, but today I'm not going to do that, okay? I'm going to do a lot of writing with a pen and have you take notes that way. The math that I'm teaching lends itself to that style of teaching, okay? I really don't need to write a lot of stuff, I really don't need to type a lot of notes so much. It's just work problems out for you, okay? So having said that, here we go. Let's start off by looking at the difference between solving and simplifying square roots, okay? Solving and simplifying square roots. Now, first of all, I would like you to copy this in your notes, would you please? Copy down the square root of 50. I hope by now you're freshmen in high school, or 8th graders, whatever it might be. You should know by now how to find the square root of a number, but in case you've forgotten, here's a quick example. The square root of 16 is 4, because 4 times 4 equals 16. It's that easy, okay? So when I ask you to find the square root of a number, I'm asking you to think of a number that when you multiply it by itself, you get the number on the inside. Okay, that's all you're doing. So one more really quick example. If I asked you to find the square root of 100, some students would put 50, and that's incorrect because 50 times 50 is not 100. The square root of 100 is 10, because 10 times 10 is 100. Okay, so moving on. So anyways, I'd like you to copy in your notes the square root of 50. Then I want you to draw an arrow and put solve. We're going to solve this. Then I want you to draw an arrow and put simplify. Okay? So on upcoming tests and quizzes, if I ask you to solve a square root, you must know what I mean. When I ask you to simplify a square root, you must know what I mean. Do you understand? So here we go. When I ask you to solve a square root, you simply solve it. You do it in your head, or you type into a calculator. For example, if this would have said the square root, don't write this down, just listen. If this would have said the square root of 49, you don't need a calculator for that. You know the answer is 7, because 7 times 7 is 49. You've solved it, okay? So when I ask you to solve a square root, either do it in your head or use a calculator, alright? Well, the square root of 50 cannot be done in your head. It's going to be 7 point something. So let's take a calculator and type in the square root of 50. Every calculator is different, so you're going to have to figure out on your own how to use your calculator, okay? But the square root of 50 gives you 7.0716, and it goes on and on and on, okay? So there, that's solving it. Now, if that's not easy, I don't know what easy is, okay? When I ask you to solve a square root, you either do it in your head if you can, or type it into your calculator. It is that easy, okay? But what if I ask you to simplify a square root? That's a lot different, okay? Just like with a fraction. Don't write this down, just listen. If I gave you 3 9ths and told you to simplify that or reduce it, you would put 1/3, because 3 goes into 3 once and 3 goes into 9 3 times, right? Well, it's the same thing with a square root. We can reduce or simplify them, and here's how you do it. Off to the side in your notes, I want you to write down a bunch of perfect squares. Go ahead and write the words perfect squares. And let's write a bunch of them. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6. 7 times 7. 8 times 8. 9 times 9. 10 times 10. And of course we could go on and on, but that should be enough, okay? So these are really easy to memorize, just 2 times 2, 3 times 3, 4 times 4, etc. Now these are all perfect squares because we can take the square root of all of these, can't we? In our head. Sure we can, piece of cake. So we call these perfect squares. Here's what you do. Now this is not easy, so I need you to pay close attention. You take this 50 and you look for numbers that go into 50 evenly from this list of numbers. Now look, I know that 5 goes into 50, right? 5 times 10. But that's not what I'm looking for, students. I'm looking for a number from my list over here that goes into 50. Always start with your largest number and work your way to your smaller number, just like this. If I had 8/16, if I asked you to reduce that fraction, you could use 2, but it would take you longer. The biggest number that goes into both of these would be 8. So just like when you're reducing a fraction, you want to use the largest number because it's faster. Well, same thing with simplifying radicals. Use the largest number, okay? So what's the largest number that goes into 50? 25. So here's what I do. I write 25 times 2. Now, Mr. Earhart, why did you do that? Because now you can take the square root of 25. So we leave the 2 on the inside because we do not know the square root of 2. But we do know the square root of 25. So cross it off. What is the square root of 25? 5. So put a 5 on the outside. And there you go. This is solving it. This is simplifying it. Do you understand? Now, Mr. Earhart, just like in a fraction, when we're reducing a fraction, sometimes we can reduce it more. How do I know I can't simplify this further? Good question. Check your numbers. Do any of these numbers go into 2 evenly? No. So you know you're finished. Okay? Now again, we could include this list and make it a lot longer. But really, we don't need to do that for this level of class. Okay, we really don't need to. This is pretty much all that we need. You could go up to 121 and 144 and so on and so forth. Okay, we're not going to do that. 100 is as far as we'll need to go. So now we need to practice these. Let's practice 3 more of these, okay? You can work ahead or you can watch me. The square root of 32, if I asked you to solve that, you would simply type into your calculator and you would get out. Actually, that's incorrect. I want to make that a 2. I'm sorry, guys. Please fix that in your notes. There we go. So if I asked you to solve that, you would type into your calculator and we would come up with the square root of 32 is 5.6568, etc. I'm just going to put 5.66. You can round to wherever you want to. Any questions on that? Just type into your calculator. Now I'm going to ask you to simplify this, okay? So here we go. Look at your list of perfect squares over here. Do any of these go into 32? 4 does. But remember, you want the largest number that goes into 32, and that's 16. 16 is the largest number that goes into 32. So I write 16 times what? 2, because 16 times 2 is 32. Okay? Now, leave the 2 inside the radical. We do not know the square root of that. It's a decimal. But we do know the square root of 16 is 4. So put a 4 on the outside. And there we go. We did it. We know we're finished because none of these numbers over here will go into 2 evenly. If I'm going too fast, back this up and watch it again. Okay, let's try another one. Now I have the 3 square root of 54. Now that means 3 times the square root of 54. Or some people say 3 on the square root of 54. Whatever. I just say 3 square root of 54. Now, first of all, I'd like you to solve this. So with your calculator, you can type in the square root of 54. And then whatever you get, hit times 3. Okay, that's one way to do it. And you should get this. 22.045. I rounded that, of course. Now some of you might want to type into your calculator 3 times the square root of 54 and then hit enter. I don't care. Whatever works for your calculator is fine with me. Just make sure you know how to use it correctly, okay? Now let's move on to simplifying. Let's simplify 3 square root of 54. So, as I look at 54, What number goes to 54 evenly? It has to be from my list over here, okay? Let's see. 9 does. That's the only number from my list that goes to 54, so I'm going to write 3 square root, and then instead of putting 54, I'm going to put what? 9 times 6. Got it? Now, my square root of 6 stays the same, but I cross off my 9 because I know the square root of 9, and I put a 3 on the outside. Now, do I add these, subtract these, multiply, divide? What do I do? You multiply them, and please don't forget that. You multiply them. So, 9 square root of 6. That easy, guys. And by the way, if you want to check my work and see if I'm teaching you mathematical heresy, take your calculator and type in 9 times the square root of 6, and you'll get out the exact same decimal as when you typed in 3 square root of 54. Okay? This is the same as this. It's just simplified, just like this is the same thing as this, just simplified. Okay? Alright, now let's take a look at one more. We're going to move on to some other problems, alright? It's going to be a pretty long video today. We have a lot to do. Alright, now last one, I'll go a little faster. Square root of 16. If I asked you to solve that, you would simply have put 4. Okay? And if I asked you to simplify it, guess what you would put? 4. So anytime you know the exact square root of the number inside the radical right here, this box is called a radical. This number here is called the radicand. The radicand, C-A-N-D. C-A-N-D, radicand, okay? Anytime this radicand is a perfect square and you know the square root of it, then these two answers will be the same. If you solve it, you get 4. If you simplify it, you get 4. Alright? Okay, easy enough. Now, moving on, I want to look at multiplying square roots and then simplifying them, okay? So please take some really good notes. We're going to do 2 of these, so here we go. I would like you to write down 1/2 square root of 32 times the square root of 2. Got it? Now, listen carefully, please. Multiplying square roots is a complete piece of cake. You just have to know how to do it, but it's really easy. I don't think these are exact mathematical terms, but I call this my outside number because it's outside the radical. I call this my inside number, okay? So, when you're multiplying radicals, you multiply the outside number times the outside number. And if there's no number here, you can put a 1 here if you want to. It's totally fine to put a 1 there if you want to, because 1 times the square root of 2 is the same thing as the square root of 2, okay? So you multiply outside numbers times outside numbers, and then inside numbers times inside numbers. So here we go. 1/2 outside number times 1. Outside number 1/2 times 1 is 1/2. Inside number times inside number 32 times 2 is 64. And look at that. Now I want you to solve it, and I want you to simplify it. Got it? Okay. To solve it is pretty simple. I have 1/2 times the square root of 64. Well, the square root of 64 is 8. So I really have 1/2 times 8, correct? And 1/2 times 8 is 4. And if you simplify it, remember you get the exact same thing. Anytime you have a perfect square in here, the solving answer is the exact same thing as the simplifying answer. Always. Got it? Always. Okay? This is a perfect square, so the radical is totally gone. So whatever I get from my solve answer is the same as my simplify. Let's try one more. We're moving on to something else, alright? Now, let's review. So far we have learned the difference between solving and simplifying, and now we're looking at multiplying square roots, okay, and then simplifying them. Please copy this one in your notes. 2 square root of 8 times 4 square root of 25. Now you can work ahead if you think you know how to do this, or you can watch me. It's up to you. If you choose to work ahead, remember, in the end, I'm going to have you solve it, and I'm going to have you inside number times outside number. 2 times 4 is 8. Inside number, or it's also called a radicand. Radicand times radicand, or inside number times inside number, would give you 200. Alright, now let's solve it. So with your calculator, 200 is not a perfect square. It's not. So we're going to multiply 8 times the square root of 200, and we're going to get 113.14. I rounded that off, of course. 113.14. Okay? Make sure you know how to work your calculators correctly. Now, if we're going to simplify it, we need our list of perfect squares. Alright, so there it is. Now, 4 goes into 200. 25 goes into 200. But 100 does too. Remember, always try to get the largest number out of this list. It will save you time, okay? So I'm going to put 8 square root of 100 times 2, because 100 is one of my perfect squares, and it goes into 200 evenly. So 100 times 2 is 200. Now, my square root of 2 stays the same. Cross off your 100. The square root of 100 is 10, so I'm going to put a 10 on the outside. And of course, you multiply these two numbers together. So there you go. 80 square root of 2. By the way, if you want to check your work, take your calculator. This is a great way to check your work. Take your calculator, type in 80 times the square root of 2, hit enter, and you get this exact same decimal over here. Okay? So we have looked at so far how to solve and simplify square roots, and we have looked at how to multiply them and then solve and simplify them. So lastly, let's look at simplifying square roots that are in fractions. Now I've saved the hardest for the last, so be ready to really think here, okay? Before I jump into this, I need to teach you something that's a mathematical principle or truth. Are you ready? Please write this down. Please write this down. If I have the square root of something like 1/2, that is the exact same thing as the square root of 1 over the square root of 2. We call that splitting up a radical. So you can definitely do that, and that's going to be very helpful. Or you could also go backwards. If I have square root of 1 over square root of 2, that's the same thing as the square root of 1/2. Please don't forget that. Do you understand? Okay, here we go. Now, we're going to work 8 problems. It's going to take a while, so let's get into this right away, okay? I want us to simplify the square root. The square root of 7/9. Okay? Now remember, this is the same thing as the square root of 7 over the square root of 9. If I go too fast, just pause the video, okay? So, the square root of 7/9 is the same thing as the square root of 7 over the square root of 9. The first thing you always want to do is, I guess I can give you some steps here if you want to write them down. Always check for perfect squares. Check for perfect squares first. Well, I have a perfect square. It's the square root of 9. So now I have the square root of 7 over 3. Okay? Did I lose anyone there? So I have the square root of 7/9. I first then take that radical and I split it up into 2 radicals, and I'm looking for perfect squares. Okay? Next, you want to reduce the fraction if at all possible. And then lastly, check for perfect squares again. Alright, so if you're a person that likes steps, these will work pretty well, okay? Not perfectly, but pretty well. So, look for your perfect squares. I did that. Then reduce the fraction. Then look for perfect squares again. This is all we can do, guys. Come on, look at this. There's no more perfect squares. We can't reduce this. And by the way, oh my goodness, you guys listen, this is so important. If this 7 was a 9, I'll bet you a lot of you would say, oh, we can reduce it. No, you can't. This is an inside number. It's under the radical. This is an outside number. You can only reduce outside outside numbers with outside numbers, inside numbers with inside numbers. Do you understand? Okay? So even if that was a 9, you could not reduce this. Okay? Now if there's a 6 out here, that's an outside number. That's an outside number. No problem. Go ahead and reduce it. No problem. Okay? But you must reduce outside numbers with inside numbers. Excuse me. Outside numbers with outside numbers and inside numbers with inside numbers. That's as far as you can take that. Alright, let's try another one. Please copy this in your notes. 2 square root of 5/4. Okay? Now first of all, let's break that down. We're going to look for perfect squares. So you really have 2 square root of 5 over square root of 4. But I want to teach you something you really, really, really need to know, okay? Anytime you have a number out front like this, and you split up into radicals like this, you can put it up top and it really makes it helpful. So it will look like this. I'm not going to go into detail right now as to why you can do that, but trust me, if you have a number out front like this, it helps to put it up front, up top like this, okay? And split the radical up. Now why did I split the radical up? Because I'm looking for what? Perfect squares. And I see one right here. Look at that. Square root of 4 is the same thing as what? 2. So now I have 2 square root of 5 all over what? 2. What's the next thing I do? Reduce. Well, look at this. Outside numbers, I can reduce them. 2 becomes a 1, 2 becomes a 1. So now I have 1 square root of 5 all over what? 1. Well, guys, come on. You know you don't need this 1 down here in the bottom. And really, you don't need this 1 here. You can put all this if you want to, but you don't have to, alright? And this 1 right here is not necessary either. So there we go. So I checked for perfect squares. I reduced it. Now I'm checking for perfect squares again. I don't see any. That's it. That's as far as I can go. Okay, let's try another one. Number 3. We're going to do 8 of these, so anytime you start getting bored, just work ahead, okay? 3 times the square root of 3/16. Alright, step 1. We're going to check for perfect squares, so we're going to split this thing up. So 3 square root of 3 over square root of 16. Okay, do you see any perfect squares? Yes, right here. Square root of 16 is 4. Is this a perfect square, the square root of 3? Not at all. So now I'm left with 3 square root of 3 all over 4. Okay, can you reduce this? Well, let's see. Outside number. No, it can't be reduced. Inside number. There's no inside number down here, so no, it can't be reduced. Okay, do you see any perfect squares? No, we're done. Nothing else you can do. Prop number 4. Or prop number you know what, we might just do 7 of these. Yeah, we'll do 7 of these. Alright, here we go. The square root of 32 over 25. Alright, here we go. Step 1, we're going to split this thing up. Okay, do you see any perfect squares? Yes, right here it's a 5. So now I'm left with square root of 32 over 5. Can you reduce it? Well, outside number here, no. Inside number here, no. Inside number down here, so no. No perfect squares, but hold on. Oh my goodness, don't forget this, hold on. Remember what you learned earlier? We didn't learn earlier math just to put off to the side. True. Nowhere over here did I put to simplify, but guys, it's kind of common sense. If you've got a radical that can be broken down, you've got to break it down. 32. Can you not simplify that? Yes, you can, so you have to. Do any of these numbers go into 32? 16 does. So off to the side, I'm going to break down 32. 32 is 16 times 2. Cross off the 16, put a 4 on the outside. 4 square root of 2. So now, instead of putting square root of 32, I'm going to put 4 square root of 2 all over 5. Now I know I'm finished. How do you know that, Mr. Earhart? Well, do you have any perfect squares? No. Can you reduce anything? No. Can we simplify any of our radicals? No. That's it. Now if this were an 8, then And you can simplify the 4 and the 8, okay, but they're not. Alright? So we have to leave it like this. There's our answer. That's a good problem. Alright, let's try another one. Yeah, we're just going to do 7. This is problem number 5 right here. Alright, square root of 49 over 4. Okay, step 1, break it up into 2 radicals because we're going to look for perfect squares. And lo and behold, look at that, they're both perfect squares. The square root of 49 is 7. My fault, that should be a 4 right there. And the square root of 4 is 2. And we're finished. You can't reduce it. There's no square root. You can't simplify it. You definitely don't need that. There's no square roots to simplify. So we're good. Alright, moving on to the next problem. Alright, number 6. Square root of 32 over 50. Alright, step 1, we're going to split it up and look for perfect squares. Do you guys see any perfect squares anywhere? I don't. So next, we're going to do what? Reduce it. I believe 2 goes into both of these numbers. 2 goes into 32 16 times, and 2 goes into 50 25 times. So there, we reduced it, okay? Now, look for perfect squares again. We have the square root of 16 over the square root of 25. And look at that, the square root of 16 is 4. And the square root of 25 is 5. Look at that, 4/5. One more problem, students, and we're finished. This will be a longer problem. Okay, now, before we get into using our steps over here, I would definitely first multiply my 2 radicals up top. Square root of 160 over square root of 5. Okay, that's the first thing I would do for sure. Square root of 10 times square root of 16. Your outside numbers are 1 and 1, so 1 times 1 is 1. We're not worried about that. And then inside number times inside number is 160. Alright, next. Do you see any perfect squares? Not at all. Next. Can we reduce it? Well, I think so. I mean, inside number 5 goes into both of these. So I would do it like this. I would say we have the square root of what? 160 over 5, which reduces to the square root of 32 over 1. Okay? 5 goes into 5 once, and 5 goes into 160 32 times. And 32 over 1 is just 32. So this equals this, which equals this, which equals this. Got it? So I've taken this and I've broken it down all the way to this. Now we're not finished because, remember, sometimes you can reduce those more, okay? So let's see if we can simplify or reduce this radical. 16 goes into 32. 16 times 2. Cross off your 16, put a 4 on the outside, and there's your final answer. 4 square root of 2. So this entire mess that we started off with right here, square root of 10 times square root of 16 all over square root of 5, is the exact same thing as 4 square root of 2. Okay, guys, I hope this helps a lot, guys. If you have any questions, don't hesitate to call.